We would like to extend our greetings and express our gratitude for your presence at this gathering on behalf of its chain. We aim to give you a brief overview of our company and present our innovative proposal for the telecom market, particularly in the field of number portability. Its chain is a company that was founded in 2019 by Leandro Iglesias and Miguel Scavo. The company's primary aim is to develop blockchain projects. Leandro had an idea for a payment reconciliation system, while Miguel had developed an academic thesis on number portability using blockchain technology. It was decided to combine both ideas, resulting in two projects that are currently underway in the company: NPM, Number Portability Management, and the Reconciliation and Payment System. NPM includes modules for managing numbering plans and modules that handle the number portability process. The commercial version of NPM is currently being installed, while the Reconciliation and Payment System is in the final stages of conceptual design. After conducting extensive studies, we have discovered that the number portability market has vast potential, operating in more than 113 countries worldwide and having a market value of over $531 billion. We have gathered data that reveal some interesting metrics, such as the average cost of number portability being $1.60 per transaction and the annual percentage of lines ported from one operator to another being only 4.14%, which is relatively low. These findings suggest that its chain has a lucrative business opportunity due to the market's growth potential. We have conducted extensive studies on number portability in approximately 24 countries, particularly in Latin America. Our research covers all 5 continents, although some areas have only partially been studied due to difficulties in obtaining data. One significant piece of global number portability information is that China joined in 2019, and Uruguay joined in 2022 at the Latin American level. We aim to demonstrate the depth of our research and understanding of portability, allowing us to make a proposal based on private blockchain. We have worked extensively with information from Colombia, Panama, Canada, and Peru and covering all 5 continents. We have collected data that makes us confident and solid in our study and, above all, understand the key players in the world of number portability. The table below summarizes our investigations, showing the number of subscribers and the number of lines that are ported annually. It has been an arduous task, but through our research, we have better understood portability and its challenges. In the countries studied, Telcordia holds the largest market share, with 21%, followed by Medifon with 17% and Informatica Corte Inglés with 13%. Telcordia is based in the United States and dominates the telecommunications market of the most advanced countries. Medifon, a group of companies based in Lithuania, controls the market with influence from Russia. Informatica Corte Inglés, originating from Spain and now French/Arab, is predominant in the Latin American market. Local integrators are chosen to work in other countries, such as Brazil. This practice is also common in China, India, and some Arab countries. Latin America presents a great opportunity, but previous experience is required, which is why we are working on the regulation of each country. We have sent a request to Colombia with the necessary regulation changes. This is part of our first round of approaches with Latin American regulators, and we have received satisfactory feedback. In this slide, we have presented information on 8 Latin American countries. The information includes their revenue, total lines available in the market, and the proportion of lines that are ported annually. We have also differentiated between the revenue generated from fixed charges and variable charges. Interestingly, countries with larger markets and a percentage of lines ported annually above 10% follow a 100% transactional business model. In contrast, in smaller markets where the rate of lines ported is below 5%, fixed cost models are included to ensure the sustainability of the portability model and associated costs. To better understand the concept of number portability, it is essential to have a general understanding of the life cycle of a telephone number. The process typically starts with the operator requesting a numbering plan from the country's regulator. After being granted authorization, the operator is then allocated a telephone number by the regulator, which they assign to a user of their telephone service. The user is responsible for initiating the number portability process if they wish to switch to a different operator while retaining their existing phone number. Unused telephone numbers must be returned to the original database, and the operator must reassign them to another subscriber according to the set rules. It is crucial to understand this life cycle to understand how the system operates clearly. In the field of number portability, we have noticed several challenges that regulators and operators face. The regulator has to deal with high implementation costs, lengthy validation times for number portability conditions that depend on the donating operator, and constant audits required to reconcile the databases held by operators with the administrative systems database. These issues can cause significant problems for the regulator. On the other hand, operators face difficulties in synchronizing user databases and numbers between operators, which is essential for maintaining a clean routing table. This, in turn, prevents incorrect call routing, leading to costs and a negative perception of the service provided due to failed call completions. Operators also face challenges when trying to trace a number's complete history since its assignment. This capability is vital for tracking the number's ownership over time, formed by the operator-user pair. However, current systems have limitations, where ownership is lost or tracing becomes cumbersome. Issues related to user authorization distrust arise as processes rely on outdated documentary forms, which results in delays. Some fraudulent users abuse commercial offers and find loopholes in the operator's systems, which leads to abusive practices. This, in turn, increases the level of process controls and causes delays in user authentication. We have observed specific challenges faced by subscribers during the number portability process. These challenges include the complexity of authentication procedures required to initiate portability. Additionally, a lack of information provided to subscribers throughout the process leaves them unaware of the step-by-step progression. Subscribers also experience delays in the validation of conditions. Furthermore, it becomes difficult for subscribers to seek assistance and take appropriate actions when portability could be more effective. Resolving such issues and assigning responsibility can be particularly challenging in some countries. These issues collectively pose significant barriers to the advancement of number portability. Integrating the numbering plan and portability process can facilitate effective management of the crucial resource, the telephone number. This is a primary impediment to competitiveness in markets. By linking the telephone number with operators and users within a notary system boasting clear, negotiated, and agreed upon rules, we establish a foundation for enhanced efficiency. Envisioning an integrated system incorporating SM and IMEI of phones promises heightened effectiveness against fraud and theft. It opens avenues for immediate portability processes with the latest generation mobile phones, complemented by whitelists and/or blacklists of telephone numbers, users, mobile phones, and even operators. This represents a pioneering approach. Blockchain records the subscriber's authorization regarding the number and all associated transactions. The country would possess an integrated database encompassing the numbering plan and all subscriber transactions tied to specific numbering plan numbers, all underpinned by private blockchain technology. This heralds a significant shift as the system synchronizes with immutable real-time information regarding each number, ensuring 100% traceability. The system is equipped with automated conditions for portability through smart contracts. We advocate for pre-checking these conditions to determine eligibility for the number portability process promptly. From the regulator's standpoint, our system streamlines costs through distributed implementation and obviates the need for constant audits to reconcile differences between various databases. This does not preclude audits, they remain feasible as all actions are recorded on the blockchain. This feature underscores the essence of our proposal: traceability and security. Importantly, this intrinsic characteristic eliminates the necessity for continual audits. Our platform provides a user-friendly experience to our subscribers. Every subscriber is given a personal user account, which can be accessed through a mobile app or web platform. This account allows them to view all available numbers categorized by operator. Subscribers can easily initiate the process and keep track of its progress. We perform a pre-check of conditions to ensure immediate implementation, making the experience smoother and faster for subscribers. What are the foundational pillars of our system, and how does it differ from traditional systems? Our proposal is based on distributed ledger technology, DLT, or blockchain technology, and we highlight the following differences. 1. In our system, we consider telephone numbers as the most critical asset in the database. In contrast, traditional systems consider them as mere spreadsheet data. 2. Our blockchain system empowers subscribers through the application, while traditional systems vest authority in the operator, often granting veto power. 3. We advocate for pre-checking conditions to minimize rejection transactions, while traditional systems employ post-checking. 4. Our blockchain model offers versatility with flat fee, transactional, or hybrid models that are adaptable to market conditions. In contrast, traditional systems lean heavily on transactional frameworks. 5. Existing telecommunications processes remain siloed, with numbering plans, portability, fraud prevention, and SM distribution treated separately. Our proposal integrates existing telecommunications processes, starting with numbering and portability and then fraud prevention, theft mitigation, and SM distribution in subsequent system generations. As we delve deeper into the concept and core pillars, we can identify 4 essential elements that define the relationship between the system and its stakeholders. 1. The portability processes reflect the inherent distrust among system participants, which include regulators, operators, subscribers, and authorities. These processes can become complex and loaded with numerous checkpoints, leading to friction among stakeholders. However, our blockchain-based system transforms this distrust into a more efficient and dependable process, ensuring seamless operations. Our system revolves around stakeholders and a primary asset, the telephone number. Transactions occur over this asset, documenting the ownership of the telephone number during the portability process. 2. In other domains, one of the significant challenges of blockchain lies in digitally representing the assets it handles. For example, digitizing and registering a property correctly poses hurdles in both tangible, real-world, and legal realms. However, in our case, the asset is the telephone number, which is born digital and legalized by the regulatory entity. It exists in a digital format, similar to digital currency, and can be managed seamlessly, eliminating such barriers. This scenario aligns perfectly with our solution for number portability. 3. Smart contracts establish immutable rules, requiring consensus among all parties for any changes. These intelligent algorithms pre-validate the conditions of the telephone number to facilitate portability seamlessly. 4. Regarding ownership of the number, our system operates similarly to a public notary, authenticating actors and procedures as the telephone number changes hands, from its origin at the regulator, through operators, to end users. Our system's blockchain boasts the following technical specifications. Private, only individuals authorized by the administrator can participate. Closed, it operates exclusively within its designated scope. Distributed, each node maintains an identical real-time copy of the database. Non-anonymous, user activities on assets and transactions are readily identifiable. Tokenless, it does not function as a currency stored in a wallet. dApps Type I, our application directly alters processes on the blockchain, which is classified as a Type I application. We developed our blockchain using Hyperledger Fabric technology, a widely recognized standard in corporate blockchain systems endorsed by major technological entities like the Linux Foundation and IBM. Our architecture is cloud-based, utilizing Kubernetes, and hosted on IBM infrastructure. In May 2021, its chain was accepted into the IBM Startup Program. We are actively working towards establishing platform support in the cloud and aiming to develop it as a distribution channel for our system. Our system is composed of 4 crucial components. Firstly, the blockchain serves as the secure foundation where all transaction information, such as number ownership and statuses, are stored. Secondly, the smart contract verifies different conditions like contract terms, arrears, and types, which may vary from country to country. Thirdly, the user interface includes a web platform for administrative tasks relating to the numbering plan and number portability processes. We also offer a powerful mobile application that allows end users to initiate and track the process, providing them with a digital approval certificate, QR code, for portability. Lastly, the API acts as a connection between the external world and the blockchain. Operators receive real-time updates on the status of telephone numbers through this API and can transmit the necessary information back to the system. We currently have a fully operational bot that simulates this function. While some countries manage these processes separately, others aim to consolidate all telecommunications-related activities into a single, centrally managed system with distributed technological infrastructure. This strategy leverages the competitive advantages of blockchain technology. The table below outlines the 2 primary processes and the necessary subtasks required for seamless system operation. It also includes columns indicating the authorized roles responsible for executing these tasks. Integrating numbering plan management and the portability process within the same system is crucial, as the former serves as the primary input for the latter. This slide combines the principles stated in ETA-T Recommendation E164, Supplement 2, with our private blockchain proposal. The ETA recommends 2 databases, the portability database overseen by the ABD, in our case, the NPM system, and the operational database used by operators' switches. Each operator should deploy a blockchain node with a precise portability database copy. This approach ensures that synchronization between the databases happens locally, distributedly, and in real time, making the system resilient due to its distributed architecture. The top section of the graphic shows how the NPM system integrates with blockchain technology. It's important to note that all updates occur within the blockchain, specifically within the portability database, via the NPM system, which then updates the operator system's databases, OPDB. This process can occur online, during synchronization windows, through batch processes, or through a combination of both. We have configured a system that enables us to propose to the ETA that blockchain technology can be used to centralize all data. The blockchain updates in real time, eliminating the need for synchronization windows between the online database and the databases managed by operators and their routing systems. We are considering presenting this approach to the E2. In our smart contract decision flow, we have outlined our system's algorithm, which is partly inspired by Colombia's regulatory framework. The process starts with the following validations. Verification of the number type field. If the number is designated as fixed, we verify whether the receiving operator offers service within the specified area using the number's area code. Assessment of the contract type. We distinguish between prepaid and postpaid contracts. Evaluation of contract duration. This involves managing a timestamp within the system, which is reset after each portability. Scrutiny of the number's arrears status. These rules can be adjusted to suit the specific regulatory landscape of each country. Although our model takes inspiration from Colombia's regulations, Colombia has recently removed the requirement for a fixed contract duration due to inefficiencies and process delays. During our discussions with Colombian authorities, we have emphasized that the goal is not to eliminate conditions but to ensure they are fulfilled efficiently, making them genuinely valid. Since this change, there have been several cases involving the Commerce Superintendent, the Regulatory Commission, and operators, which have resulted in fines for malpractices. Recent efforts have aimed to enforce asymmetrical regulation against certain operators, highlighting the inherent friction within the system. Our proposal tackles these challenges at their core. When it comes to evaluating the performance of a proposed system, one of the key questions that arises is whether it can handle the daily transaction volumes in different countries. The answer to this question is a resounding yes. To provide a better understanding of the performance capabilities of private blockchains implemented on Hyperledger, let's compare some statistics. The first table compares the transaction volumes of credit cards, public blockchain networks, and Hyperledger organization data, all measured in transactions per second. The second table shows the daily transaction counts for portability transactions in different countries. For instance, let's consider the United States, where an average of 153,367 transactions occur daily. Even if we were to conduct all these transactions within a 6-hour period, it would only amount to an average of 7 transactions per second, which is well within the manageable range for Hyperledger's blockchain technology. Moving forward, we plan to conduct our own testing in the first quarter of 2024. This will involve deploying the standard Caliper application and using our bot to run simulations. These tests will allow us to compare our results with the existing literature published by Hyperledger, giving us valuable insights into the performance capabilities of our system. Each party involved in the NPM ecosystem has distinct responsibilities. NPM, authenticating subscribers, validating regulatory conditions, monitoring the process, and issuing reports. Regulator, managing the numbering plan. Operators, provide subscriber information, telephone number parameters, such as arrears, contract type, and number status updates, and any other parameters used for portability decisions. Subscribers, initiating the number portability process. Updates from both the regulator and operators can be executed online or in batches, as per regulatory stipulations. However, we recommend real-time online updates because blockchain technology is well suited for such operations. Our defining features are: private blockchain technology, break traditional scheme. Subscriber user power. Independent and direct communication channel between regulator and user, without going through the operator. It is not only a portability tool but also a direct communication tool. Solution that covers a greater number of users. Inclusion. Ability to adapt to regulatory changes in different countries. Traceability, immutability, security, auditability, decentralization. Transactional record. Pre-check, zero rejection transactions. Functional, friendly solution, QR code. App available to the subscriber. Light, fast browsing, does not require higher bandwidth. Partnership with IBM. Please contact us and subscribe to get access to our application at npm.itschain.com. You can explore the potential of our ItsChain blockchain in real time. Visit itschain.com for more information about our company, news, and ongoing projects. The incorporation of distributed ledger technology, DLT, into the portability process is no longer just an option, but a necessity. Our CEO and co-founder of ItsChain, Miguel Scavo-Salvi, rightly stresses the importance of this integration and highlights the need to turn the phone number into a blockchain asset. This game-changing step will not only revolutionize the industry but redefine it. Scavo's argument is compelling. The system's ability to minimize process friction and eliminate bad practices will bring about a significant transformation in the industry. By leveraging blockchain technology, we can ensure that the specific conditions of each country are met and maintained, without relying on shortcuts to speed up the process. Incorporating DLT into the portability process is the way forward, and we must not delay in taking this essential step. Its chain is committed to leading this revolution, and we invite you to join us in this journey towards a more efficient, secure, and transparent future.